Today I'd like to introduce you to this very large Scotch Marine fire tube steam boiler. This is a dual fuel boiler and it is a Cleaver Brooks rated at around 14 MB or 14 million BTUs. Let's take a look at some of the components in the order that they would start as this boiler begins its cycle. On a call for steam from the heating controls, one of the first things that's going to happen is the combustion air fan is going to be energized. This fan is going to draw air in from this room and blow it through the combustion chamber to purge it of any combustibles that may be present in there from the previous cycle. Air is let into the boiler room through an outside air damper. This damper motor will also be energized at the same time the fan is to open up this damper and allow combustion air to enter into the boiler room. The switch up above it, a proving switch, will actually send the signal and prove to the burner that air has been opened into the boiler room for the combustion process. The next thing we need for combustion is going to be our fuel, so let's take a look. This is our main gas line and our gas train. A large gas pressure regulator, which regulates the gas pressure to the burner. We also have a smaller 3/4 line that has its own gas pressure regulator. This is for the gas pilot. Regardless of which fuel you're using, natural gas or any of the fuel oils, a natural gas pilot is going to be used to light up that fuel. We have a high and low gas pressure safety. We have two modulating gas valves and a vent valve in between. This vent valve is used to vent any gas that may get trapped between the two motorized valves during the off cycle. Once air is proven by the proving switch, gas solenoid will open and allow pilot gas to come up and enter into the burner. A spark igniter will create a spark across that pilot gas, causing that pilot gas to ignite. Once that flame is lit, a flame sensor, a flame rod, or a fire eye once again must prove to the main gas valves that a pilot is present to light the main gas. Otherwise, the process will not continue. Once pilot flame is proven, the main gas valves will open, allowing main gas to enter into the burner through a valve being controlled by a modulating motor. This particular burner is a fully modulating burner. There are many different types, from the simple on-off, which is used for small residential applications, but also very inefficient. You can have a high and low fire boiler, meaning it has two capacities, usually with two gas valves or a two-step gas valve. A fully modulating burner, which is controlling the air-to-fuel ratio with one modulating motor. Or you can have even higher efficiency burners, which use individual modulating motors on the fuel valve and on the air to get a very precise match on the air-to-fuel ratio, significantly increasing the combustion efficiency. Once main gas is lit, this modulating motor is going to modulate that air-to-fuel ratio based on the demand. As the steam pressure goes up, the modulating motor will reduce the fire. And as the steam pressure goes down, it will increase the fire, trying to match the amount of fuel burned based on what is needed or required in steam pressure. Once main gas is lit and the boiler is fired and in operation, the gases of combustion, or the leftover from the burned fuel, get sent through the fire tubes. They pass through the boiler and transfer their heat to the water that's surrounding those tubes in our Scotch Marine boiler. Now that we've taken a look at the operation of this boiler with natural gas, let's take a minute to look over some of the components for the fuel oil system. There may be times where the utility will ask you, if you have a dual fuel boiler, to come off natural gas to reduce their demand and operate your boiler on your fuel oil. This number 2 fuel oil is being pumped over from the fuel oil tank. It's passing through some strainers, over to the burner, to the main oil pump. This oil pump is discharging and pressurizing that oil and sending it into the burner, where it is actually mixing with compressed air to increase the pressure and provide air for combustion. This air and fuel mixture is then sent into the burner and lit by the same natural gas pilot, just as the natural gas was lit previously. Those gases of combustion, once again, travel through the fire tubes and pass their heat to the water that's surrounding those tubes. As the fuel oil burns, gases of combustion travel through the fire tubes and give off their heat to the water that's surrounding those tubes, creating steam. Eventually, those gases of combustion travel completely through the boiler and exit through the boiler breeching up on top. This boiler breeching carries the gases of combustion over to the chimney, which travel up through the building and are expelled up out at roof level. Many times you will see some small holes drilled in the breeching. This is in order to use a combustion analyzer. For operators and analysts alike, a combustion analyzer is a necessary tool in order to see the combustion efficiency of your boiler. Using a combustion analyzer is going to help the analyst make informed decisions about options on increasing efficiency of the boiler. So understanding the combustion process is critical to efficient boiler operation.